Good afternoon, everyone. Hope you enjoyed your lunch. We're about to start in a couple of minutes' time. Just let more folks to come in. Obviously, it's a long way from where you all had food. So yeah, let's see. I guess we'll give 30 seconds. If nobody comes in 30 seconds, we'll start.
It's never start.
Great. Pretty much full house. Thank you all for coming. Hope you're enjoying your KubeCon. How many of you is this first KubeCon, actually? All right. Wow. Yeah. This is my 8th KubeCon. I've been to all of them so far. I might want to take a break next time. I'm thinking, albeit it's kind of nice. San Diego would be a cool place to go to. I've not been there yet. Anyway, well, hope you enjoy the rest of the show, and the talks here and other tracks. So this is the CI/CD track. Just to be clear, anybody in the wrong room? Anybody here not interested in CI/CD and would rather go to another talk elsewhere? Okay. Seems like everybody's in the right room. That's great. I think the distances in this building are rather surprising, but it's not too hard to find rooms. They're fairly well signposted. I think that's a fairly good thing, isn't it? So I'm glad many of you have found your way here. And we should probably start now. So we have a few interesting talks in this track. There will be a panel. I think the next talk will be a panel, so I'd encourage you to stay for the panel. And we have a fairly diverse set of opinions on the panel, so I hope you'll all enjoy the panel. Coming up now, we have a talk about Canary with K, as everything in Kubernetes world is with a K. And we have David here. And his colleague, friend? Cédric, yeah. All right, folks, shall we begin? It's a Canary automation of Canary deployments with CRDs and operators. Well, one CRD and one operator. How many? You tell us.
One more. One. It's going to be just one. So welcome to this presentation, obviously Canary with a K. And it's going to be about an automated and integrated way of doing Canary testing in Kubernetes. And we are in the track about extending Kubernetes, so we will explain also how we have built this operator on top of a custom resource definition. So I'm David Benque. I am working as a software engineer at Amadeus, and here is Cédric Lamorinière working at Datadog as a software engineer also. So a quick recap about what Canary is. Obviously, you know that, but when you're running a big distributed system, you have your application running, many instances of servers running in your Kubernetes, and when you want to roll out a new version of your software, the only thing that you want is maintain customer satisfaction and not break anything. So how do you achieve this? You start loading few instances of the new version of your application or new configuration, and check how this behave. You monitor this very closely. And if you're happy with the result that these Canary instances are delivering, you just roll out your new version. If not, you just stop your deployment. So today, you probably already do Canary testing. Okay? I'm wondering here in the room who has built some kind of homemade solution to do Canary? Okay. Who's using Spinnaker, maybe? Oh, about the same proportion. And any other product, you're doing Canary with something else. So we have also some other guys. Here what we are proposing is something completely integrated, native Kubernetes solution. What I mean here is that to perform the Canary deployment that we're going to show, the only thing that you need is kubectl and a new YAML file that is representing our CRD. You will see some example later on. We will offer you the possibility to schedule this Canary, starting now or in 1 hour. And it's going to work on top of the existing objects, meaning that if today you have already some tooling working on top of deployment, on top of pods and everything, it's going to continue to work with this solution. There's not going to be any changes for your existing ecosystem in theory. For example, we preserve the deployment history if you're using it. And we're going to see that with this proposition, you will be able to run multiple Canary test campaigns on the same deployment at the same time. This could be useful if you have different developers working on different features and they want to test on the live system exactly at the same time. So, Cédric, can you tell us more?
So yes, so when you want to put in place a Canary deployment, you need to think about 4 things. First is how you scale your Canary deployment. Then, which traffic you will send to this Canary. After, how do you want to validate it? And at the end, how you apply the new version. With our solution, we define several configurations for each of these topics. First thing is about the scale. You can configure it as a fixed replica. For example, 1 pod for the Canary, but you can also ask the controller to create an horizontal pod autoscaler on top of it. The percentage of replicate is something that we are thinking of, but we didn't implement it for now. For the traffic management, you may have no traffic at all on your new pod instances. For example, when you have a dequeuer that retrieve from Kafka a topic, no need to receive traffic. But you can also configure it as live traffic. Test traffic, meaning that it's your own traffic that you inject on top of your Canary, or you can also request both live and test. For Istio, you can also think about putting shadow traffic on this deployment, or tag traffic. For the validation, we have several ways to validate it. The first one is manual, meaning that at one point, someone will need to update the custom resource to say this Canary deployment is valid. But we have implemented a way of doing it with a label watch, meaning that if one labels appear on the deployment or the pod, the Canary pod, automatically the Canary deployment will be flagged as a failure. You can also send a PromQL query against a Prometheus server. We implemented a HTTP custom endpoint, like where you need to respect the format and receive the response. And we are thinking also to implement metric server in order to be able to retrieve the metrics from other metrics provider. And the last part is how do you apply the new version if the Canary succeed. So you can do a automatic rolling update, or you can run it at dry run, for example, if you only want to test your new application. So let's see an example of the custom resource Canary deployment. In the spec part, what you need to provide is a deployment name that you want to test. The controller needs it to retrieve some information on the current deployment object. Then the service name, if you want to send live traffic on it. And after, you have the different topics that I presented before, the scale, the traffic, the validation. And last part is the template. This is a new version of your deployment application that you want to test. For the scale here, as I said, we choose replicate equal 1, meaning that only one pod will start. We choose both traffic, so test and live traffic, and we use a manual configuration. We choose also to put validation period of 15 minutes, so the Canary will run at least for 15 minutes before deciding if it succeeds or false. Another example with the label watch. Here we define that we want to look at a label monitor alert iCPU on the pod that will run your Canary code. Last example, this is with a PromQL query. You provide the endpoint for the Prometheus server, the query that you want to run, and the range of the values that your pod should respect in order to be valid. We have also another parameter that is valid for the other initial delay. It's to start querying Prometheus server and other metrics solution after 20 seconds, because sometimes your application needs to have a bit of time, like if you have a cache inside, to have the proper metrics apply. So this is a representation of your application. You have a deployment on top, replication set of pods, and the services who target your application. So when you create the custom resource Canary deployment, automatically the controller will watch your deployment, retrieve some information of it, create a new deployment in parallel of your current deployment with a new pod template. and a new services, the Canary test services, to receive the test traffic. If you choose to put HPA, it will also create the HPA with the proper configuration to scale only this pod and not the other pods. If you choose to put both configuration for the live traffic, we will configure your pod template in order to fit the label selector from your services. After the validation period, if everything is going well, the Canary deployment will be flagged as succeed, and your current deployment, so my app deployment, will be updated, and you will have the version 2. So like this, we respect the history of your deployment. And when you delete the Canary deployment, automatically we will cascade the deletion of all the other temporary resources that have been created to do this Canary deployment. So I think it's end of talk for this part. Let's start a live demo.
So for the live demo, it's scripted, but everything is live. Okay, I have a cluster that is running in Kubernetes in Docker. And the application, the sample application that I'm going to run is an application that is in the repo of the project. It's a simple server. And I'm going to run anytime the same image, but I'm going to change the parameter to tweak the response time or the response code of the application to make it behave differently. Okay? On the top here, I'm going to monitor the pods, so you can see what's happening on the pods. And here I will monitor the deployments object. Okay, and let's run the demo. So the very first thing is I'm creating a namespace, okay? And in this namespace, I'm going to inject the operator, the Canary operator that is going to watch after my CRD. Of course, we need role binding and deployment for this Canary object. And here it is. It's running now, so you can see that it's there. Okay, and I have even my application that is being deployed. So I'm going to reach a state where I have a namespace, my Canary operator running, and my application with 3 pods. Okay, I'm going to expose also the service, the service for the simple server through the gateway. I'm running inside the cluster Istio. Okay, so this is how I target my application, and also I'm gathering metrics from there. So I'm using the Istio service mesh, and there's Prometheus in the background running. So you can see it. The Canary pod is here, and my pod for the application is here, targeted by this service, and we should have some traffic. Not yet. I'm going to send the traffic in a minute. So I'm going to run injection, and at the same time, I'm going to tell you how I'm going to generate the CRD. Every time we have a new CRD, it's like, a new syntax. How I'm going to deal with this. We have created a plugin to ease the adoption, and there is this plugin is called Canary. So you kubectl Canary, and one of the options is generate. So you generate on top of the application deployment that is called my app, this one, and you give a name to your Canary. Here I decided to call it Batman. I'm going to receive traffic both, the option that Cédric described. So I'm going to receive live traffic and test traffic. The service that is targeting usually my application is my app. I'm going to run a validation period of 1 minute, and I'm going to do a validation strategy that is monitoring response time, and I want my P99 to stay below 310 milliseconds. Okay, that could be my SLA, for example. So this is the command, and this command is simply going to generate the YAML file for you. So here is the CRD. You can see the kind, Canary deployment. And we have then all the blocks that Cédric has described. So first of all, we say which deployment we're working on, the scale, just like in the previous slide. It's going to be scheduled right now. I don't put any date and time here, so it's going to be triggered immediately. The service, the template for the deployment, and finally the traffic and the validation. And because I choose the option with Istio response time, it automatically created for me the PromQL query that match this kind of SLA definition. You see here that there is an initial delay of 20 seconds, and the query is going to be run every 10 seconds and for a period of 1 minute. So now let's definitively inject this. So here you see already the traffic going to my application. And now I'm going to inject this CRD. So you see immediately on the right side that there are new pods being created, and you see that they are called my app Canary Batman. Okay? Now they are running. I have a starting period of 20 seconds where the Canary operator won't do anything. It's going to wash. And I didn't show it to you, but I tweaked the response time to be out of SLA. And so what happened is that after 20 seconds here, the deployment the Canary status changed. I don't know if you've seen it. The transition is from here scheduled to running after 20 seconds. And it was performing the query, checking if we are satisfying the PromQL query or not. And of course, because of my setting, it has failed. So what happened? The Canary pod is still there. It's not receiving any live traffic. It's cut from the end user stuff. But it's there for you to investigate. If you want to continue to send traffic to it, to investigate, look at the logs and everything, it's possible because the service is still there, the pod is still there, the deployment is still there. We can see here, if we go to Mesh and we go to Batman Canary, that it has received traffic for a short amount of time till it was detected as a failing deployment, and then no traffic anymore, okay? So, if I do my investigation, I'm fine, I can delete this. And as Cédric explained, only deleting the CRD will trigger the deletion of all the objects that were created for you behind the scenes. So the deployment, the test service, the pods, and everything. This is what you see here. We have the pod terminating, but we have no more the Canary service, no more the deployment, nor the replica set. So now I'm going to trigger the load of a Canary that is okay. The response time is very good for this one. So of course, it's going to run for 1 minute and 20 seconds. For 20 seconds, it's going to stay in the schedule status. So this time it's called Hulk, my guy. So I have already some pods there running. And at the end of the period, what I would like you to focus on is this window on deployment. My app deployment, my original deployment is still there. It's running revision 1, okay? And because my Canary is going to succeed, automatically, there's going to be a rolling update of the new version being triggered, okay? So focus on this window here. Here we can see that it's running. We have some minutes, so a couple of seconds to wait. What we can do at the meantime is going back to the mesh panel here and see what's happening. So there is still the line for Batman that we don't use anymore, but Hulk is behaving correctly. The P99 is still below 310 milliseconds. I'm showing things here with Istio, but this can run without Istio at all, okay? We are just taking the opportunity that Istio is providing some metrics and gathering metrics from there. But if you are not running the service mesh Istio, you can still play with the Canary operator that we are proposing here and target other systems to get the metrics. So what happened in the end, as I told you, my app is being rolled out. You can see here the pods being changed on the top right, some old pods being terminating, new ones being triggered. And you can see that here the status has gone from running to deployment updated. There is one status that we haven't seen here because it went very fast. There is the status succeeded in between. We'll see that later on. So what we can check is that on our application, I'm going to change here the refresh rate and go to 5 seconds. Okay, and this is the graph for my application. And you can see that this was the old behavior of revision 1 with some response time profile. And since it has been rolled out with a very new release and better response time, we can see really here the difference from an end user perspective. So next step, what I'm going to do is remove this one. And I'm going to trigger the launch of multiple canaries at the same time. And not only I would trigger, sorry for that, not only I would trigger the launch of 3 canaries, so there's one called Thor, there's one called Superman, one called Wonder Woman. And not only there are 3 canaries running at the same time, but I perform multiple checks at the same time, meaning that for 1 minute, I'm going to validate here, you see the keyword quantile, meaning I'm looking at the response time, and at the same time, I'm looking at the success rate. For one of them, I think it's Wonder Woman, I'm giving very good response time, but HTTP response 500. So what we can see here is that everything has gone, and at some point it has transitioned from failed, already, scheduled, running. Well, I go to the very end of this. Yeah, there is one that is still running. We still have to wait 20 seconds for some of them. I hope that it will go. In theory, there are 2 that should go to fail. Yes, we can see it now. If I go to the mesh dashboard, I can see what's happening from a metric point of view. Is that here we have our Wonder Woman Canary test that was replying very good response time, but with a success rate that is not that correct. So different reason for failing the Canary here. So, and in the end, just like before, I still have all my objects there, not receiving traffic because the period of validation has ended. And if you are focused on this window, just like previously, you have not seen any deployment of the one that succeeded, that is called Tor. This is because for this use case, it's maybe just development validation that we wanted to do and no rollout. So I have appended it here, an option. I don't know if you see it. It's try run, the one that Cédric explained. Do you want to roll out or not in the end in case of success? And this is why the very last status that you see here on the CRD is succeeded and not deployment updated like it used to be on my previous example. Okay, I hope it was clear. This ends the demo, and we are going to continue with some slides. So you have seen it. To start the Canary, just use the plugin kubectl generate, and you have your YAML, or if you already have your YAML, you can apply your YAML. And then you can go and grab a coffee, because the engine is going to run behind the scene to do all the flow to perform the Canary test. Scheduling, validation, either fail or success, and either deployment or dry run mode. So now we talk a bit about how we did that.
So it's not the first operator controller that we build to control some stuff in Kubernetes, but for this one we use the operator SDK from the operator framework that is an initiative from Red Hat and CoreOS Fox, and it really helped us to speed up the development of this solution. It really bootstraps a simple operator project for you, and like this you can focus on the logic that you want to implement. In our case, implementing a Canary deployment, but it can be as you want to implement with a CRD and the operator concept. Another very great thing that you can find in this framework and SDK is you can very easily do unit tests on top of your logic, but also end-to-end tests. And this, we didn't find it in any other framework to do this. We can still improve this framework. Some features are missing that can really help developers like us to implement a very good support of custom resource, like the validation of the custom resource thanks to a webhook, or the implementing the proper webhook for the version conversion of your custom resource. For the first one, an issue is already open and work is in progress. For the second one, I think we are still missing some part of it to have it soon. So only with these 4 commands, you are able to create the skeleton of your operator. First one, very simple, is just to create a new folder to put your code. Then you call the new Canary command. It will generate the skeleton of your operator. After, since you want to create a custom resource to define your logic, you use the add API, give the name for your API version, and the name for your kind. In our case, Canary deployment. And after, the thing where you will put your logic is the controller. And for that, you have another command, add controller, and you give the information of which object you want to react on inside the controller. And what you need to do at the end is only to implement this method that was created for you. You receive its name reconcile because it's the concept of reconcile loop to implement your logic on top of Kubernetes resources. And the input is a reconcile request, and it's only the information of the namespace of the name of your resources. You get these instances from the client inside the framework. And after, you build your logic on it, and you just need at the end to reply result or not. The result, if it succeeds or not, with an error, or if you want to requeue the object, if, for example, you updated another object, so you want to reapply this control loop a second time to validate that everything goes well. So we wanted also to talk a bit about some traps that we failed using this framework. So a lot of magic happened behind the scene. I don't know if some of you already built some controller, but here I didn't talk about any cache, working queue, and other concepts that you need to understand normally to build a controller. So sometimes you are blind about some issues that you have inside the framework. First one that we face is depending on the Kubernetes version that you are using, the custom resources are not handled the same way. From the version 1.10 of Kubernetes, the status of a custom resource is a sub-resource. And so how you update it is different depending on the version of your Kubernetes cluster. And this is not handled by this framework. Also, talking about validation of custom resource, if your YAML file is not valid, you will not be called in the reconcile loop. But you don't have any logs neither in the framework or of the operator to say that I wasn't able to decode these resources. So we lose a bit, maybe 2 or 3 hours looking at the code of the framework to understand what's happened. At the end, we saw that the error wasn't checked at this point. Another error that we face is the log level support inside the framework. So this is fixed. Before it wasn't supported, so we tried to put some nice log level, and we didn't see what we wanted.
So a few tips also. If you are Istio users and then that you are developing also controllers, I invite you to put this annotation, sidecar Istio inject false. The reason is simple. In theory, when you run a control loop, you are not exposing a service at the same time, so being in the service mesh does not give any value here. When you want to do unit test, Cédric said that there's a good test framework, and when you want to run your end-to-end test, probably you have to expose your services. We are running Kubernetes in Docker for the test. We used to have Minikube, but we found some good advantages of going for Kubernetes in Docker, especially the way you handle resources on your local machine. And if you want to target the service inside this cluster, in the end-to-end test, most probably you will have to use the kubectl proxy and go through the API server proxy. If you want to run a demo just like the one I have done with Kubernetes in Docker, just be aware that you are not allowed to expose node port for the moment. So you'll probably have to use port forward and deploy some kind of ingress in your Kubernetes in Docker. In my case, it was Istio. As a summary, so the Canary project itself, it's running. You've seen a demo. There are a few strategies implemented already. We have some extension that we would like to do. So if you are thinking about anything to extend this project, please tell us, send us issue on the repo. You have the link here on the GitHub. And also, you're welcome for any contribution. Finally, it's never been so easy to create an operator. All the boilerplate code here, workers, informer, cache, retries, throttling, many things, you have to understand them, but they are coded for you. You really have to understand them, and I think it's the time for us to thank one of our colleagues, Salvatore Dario Minone, which at some point in time explained us all this stuff. And now if we're able to write clean control loop, I would say it's thanks to him somehow. I'm saying it's easy to create an operator, but creating a control loop, you have to put yourself in a specific mindset, okay? It has to be able to recover the loop anytime, the process needs to be stateless. There are few things that you need to understand, really. Even if the framework helps, there is few things to take into account. So this ends this presentation. I hope you enjoy it, and I hope that you will use the Canary project. Thank you.
Thanks very much.
Thank you.
Questions? We have a few minutes for questions. Please raise your hands. All right. One over there. You got a question here? I'll come to you in a second.
Hello. Thank you for a great presentation. I have the same accent as yours, so forgive. Do you plan to have some kind of extension or plugin or whatever to handle extra resources, external resources, like for instance, if you are using API gateway to, do the to be built on top and destroy, created and destroyed on top of the cycle of the Canary?
You mean for the validation period?
Yeah,
for the validation?
For the whole thing. I mean, if you want to have additional resources.
So already for the validation time, you can extend the project by calling any external server that will give health on the pods. Okay? So this is one part of the answer, I would say. You mentioned the API gateway, so you're referring to the traffic block. So far, what we plan is to have better integration with Istio to manage tag traffic and shadow traffic. If you have any ideas about how to tune an ingress or whatever, we are welcome to take your issues.
So this demo and the entire setup that we saw was in the context of a single deployment. One deployment, one Canary deployment. Often in a Canary deployment, we need to deploy multiple pods, multiple services, multiple components together. So how does Canary deployment work in a world where we need to deploy several components together, we need to test the entire stack, whether it works or not, and then we take a decision?
Okay, yeah, so you're talking about making a Canary of a full application made of multiple pods, correct?
Generally, that would be the most common use case.
So for the moment, we are not tackling this use case. It's a unique deployment in the middle of that stack that you're describing.
Thank you.
Thanks. Any more questions? All right. Who was it?
A question concerning history of the deployment. You said that the Canary keep the deployment history, but at some time, if you delete the Canary, you lose your Canary history. There is no completion state of the Canary to maybe keep it, to make sure that you have your deployment history linked to a Canary that was used at one point in time. Do you understand my question?
No, I didn't get it. I didn't get it ready, sorry.
I'm sorry.
So this seems he got this one.
So currently, when you delete the Canary deployment, you don't have any after history to say which one was used. We can think to add annotation on top of it to give some information about when it was applied and everything to improve the history of the Canary testing. This is maybe a good use case for that.
Does that answer the question?
One question over here.
Thank you.
Okay.
I was curious if you have a way to compare your Canary replica set to the standard, or not the standard, but the old replica sets that you're running. If you have a way to kind of compare, like let's say if the CPU between the two is similar, or if it's different, and kind of have a way to alert on that, or your metrics based off of solely on the new Canary.
So you're referring to the scale part here, how many instances you would run of the Canary, is that correct? Your question?
More on if comparing the old version to the new, can you compare the stable version that's running to the new version and try to make some analysis of like, oh, if the old version had a certain, or at least was in a certain range, and the new version was outside of that range?
So here you're asking if we are able to do kind of comparison in terms of how does it, is there any deviation compared to the actual stuff?
Yes.
Yes, we do have this. You've seen in the PromQL section, here I'm using one part of the validation syntax is for having a value in a range. But we are using behind the scene a library that we created last year for circuit breaking that is able to validate deviation compared to existing pod. I don't know if you remember the slide of Cédric where you saw pod name and pod query truths and so on. There is a syntax here where you can say, I want to query all my pods that are behind the service and make a comparison of the one that are Canary compared to the rest of my workload. And if you register any deviation, okay, so here you express this deviation in percentage of a metric, it's going to kill the Canary. So yes, we can do that.
Thank you.
And you can do that also, you can do that on a continuous value, like for example, I don't know, a business value, a price of a ticket or something like this. But you can do it also on a count of a discrete metric, like a number of, a count of 500 responses.
Appreciate it.
All right, we can take 2 more questions. All right, we've got loads of questions here. Okay, well, I mean, it's not like we have to run. Okay.
Congratulations on the project.
Thank you.
In order to send just a percentage of traffic to the Canary, do you need Istio?
No. So in this demo, Istio was just involved for the catching the metrics. Okay. In that case, we were running 3 pod and we had 1 more Canary. In that demo, the Canary was receiving 25% of the traffic.
Okay, so you control it with the number of pods, pretty much.
No, we don't. And if you want to tune this a bit more, you would need something like a service mesh.
Thank you.
All right, we had 2 more hands, right? You were one of them? Okay.
Okay, with Canary deployment, can you gradually increase the traffic that you send to the Canary?
No, same answer. For that, we would need to integrate a service mesh.
There was one more person who raised hand earlier.
Here.
Over here?
Behind you. Oh, okay.
Oh, yeah. Oh, all right. Okay. Thank you. Okay, last question.
If a deployment goes through while you're running the Canary that's independent of the Canary, does that invalidate and fail the existing Canaries?
I couldn't hear the question.
If a regular deployment goes through whilst you're running a Canary, does that invalidate and fail those Canaries? So obviously the Canary is based off the current deployment. If the current deployment is updated independently of the Canaries, does that invalidate and fail the Canaries?
You mean if there is a concurrent update on the stuff? So if you modify anything in the CRD, so including the template of the deployment, it's going to restart from the beginning. It's been considered like a new Canary. Okay?
Okay. Thanks very much, everybody. Thank you. So I must say I made a mistake earlier. I didn't realize that this was actually extending Kubernetes track. I was expecting to host CI/CD track, which I think I'm still doing on Thursday. So the reference to a panel session being one after this talk was incorrect. This is extending Kubernetes track.